You hope not?
That means I have to do everything. Smart people are always sad.
I don't think I shared the right thing. Let's try that again.
Why do you have to be an Indian to be happy? I thought you said Indian.
What? There we go. All right. How'd that homework go? Fine. Following a recipe. That's all it's about. Following a recipe. All right. All right. So that was the tangent. We're moving on to the last one of the chapter.
You should record the class.
That's what I literally was doing. Yeah.
And tomorrow for Nebraska.
And coming back.
Monday. Or we come back Saturday.
Yeah.
Basically.
If you send me an email, I'll send you the practice test. If you come see me by the end of the day, I'll have it printed out.
Okay.
The practice test. Are you going to? For what?
Basketball.
Boys and girls are going?
Yeah.
I didn't know that.
Varsity.
I thought it was just one. Okay. Okay. Priscilla, you're not going, are you?
Yeah, she can
Sorry.
Didn't you play basketball in middle school?
Assistant manager.
I played
Volleyball?
in middle school.
Volleyball, naturally.
It was too short.
I remember, I saw you in a couple games.
Shoot better throws than half of the battle points.
I saw you airball after the game. I saw you.
Too bad, because now that I have that huddle thing, I can look at highlights for every player.
Really?
Yeah. You just go on huddle, you do Liberty Tree Academy, pick up whatever sport you want, varsity girls, and you can click on the girl, it'll show you their highlights. The camera records all.
Can I come in for essay?
I got somebody already.
So you'll have it printed out for essay.
I hope to, unless somebody grabbed you for period 7, but 7 is when I usually print things. If not, I'll bring it after school.
Do they have a test this Friday like I do?
You don't have a test this Friday. You've missed too much. Right. You have your test when you're ready for it. All right, everybody good? All right, seniors, you ready? You ready? One more formula. Except it's not one, it's many. Right? But one more concept, except it's 2 concepts. Concept number 1 is,
Stop lying.
concept number 2 is, if my lips are moving, I'm probably lying. All right. Yeah, double angle and half angle. Now, the reason why we're getting 2 of them, and there's going to be multiple formulas for all that, sine, cosine, and tangent, right? So the reason why we're doing 2 in one day is because you already know the process. The process isn't going to change from the last 3 days. Establish identity, find the whatever double angle, half angle of this particular degree. You already know the process. So all I now need to do is prove the formula, the recipe, and then just do some applications of it. Okay. Of the 2, double angle straight, easy, no issues whatsoever. Half angle, there's one little type for sine, cosine. You add one little extra thought to it. And the thought is pretty straightforward in these. Okay. So I'm going to give you a bunch of new identities today. So you're going to get a double angle and you're going to get a half angle for both sine, cosine, and tangent. So here we go. So this is a double angle formula. As the name implies, what would double mean? So it's going to have a 2 involved into it, right? So double angle, right? Instead of it saying alpha plus beta, it's going to say, that wouldn't be 2.
2 alpha.
It would be 2 alpha or 2 beta, right? In other words, you're going to take one of these alpha or beta and make it the other one. So instead of having 1 alpha, you got or 2 beta. Instead of using alpha or beta, they use theta, right? They could have used alpha, they could have used beta, they chose to use theta. So they're just going to say, assume what if, right? You made alpha and beta exactly the same value. In other words, what if you made them both into a theta, right? Why did they choose theta? I don't know, right? They could have chose alpha or beta. So how many thetas do I have now? This is why this is called the double angle, right? Because you have two of the angles, 2 times the angle. Okay. So here we go. So I take my initial recipe, which was sine, and anywhere I see an alpha or beta, I write theta. All right. Can you see what you wind up with? It's the easiest proof of the year. What do you wind up with? Look at what you got.
2 sine plus.
Not 2 sines and 2 cosines.
2 sine times. Cosine squared.
2. Hey, vanilla. How many vanillas do you have? So I have 2 of what?
2 sine.
You have to put a theta in there.
2 sine theta times cosine.
That's what you get. Is that the easiest proof of the year? I'll have a slide where we write everything down. You have to write it down yet. So there it is for sine. That was easy. There's the recipe. What do you need for the recipe? Well, no, look at the recipe. What do I need for the recipe? I don't care about the 2. That's just multiplied by 2. What do I need for the recipe though? I need a sine theta and a cosine theta. If you have a sine theta and cosine theta, take those 2 values, multiply them together, and multiply by 2, and you're done. Easy, right? If all the proofs could be that easy, right? What about for cosine? What am I going to do? It's the same proof. What am I going to do? So cosine 2 theta is going to be equal to what did we do with the first one? How did we get to this step? So tell me what to write. Yeah, that's what I should write, right? Well, theta plus theta is 2 theta, and now look at what we have here. No, we don't. What do we got? So therefore, what do we got? No. Look at what we have right here. What is this? What does that simplify to? No, there's not 2 of them here. That's a multiplication symbol.
Oh, 2 squared.
So tell me what I should write. We would say, and the way it's said is stated is cosine squared theta. That's what it turns into. That's pretty easy, right? Cool. Does this kind of look familiar?
Yes, equals 1.
Doesn't equal 1 because this is a subtraction. If it said plus, it would equal 1, right? But it's a minus sign. But it sure looks familiar, right? Okay. So we just said that that is true, yes? But we also said that that kind of looks familiar. It looks like, right? It looks like that one, right? It wouldn't equal -1, no. If you multiply both sides by negative, it would say negative cosine squared minus sine squared equals -1, right? But it sure feels like I should probably do something with this, right? Okay, so let's do something with this. Let's do some substitution. What's this say right there? Does that say cosine squared? No, it says sine squared plus cosine squared. So move the, okay, so I did. So now you could do some substitution for that, right? And it would say that. All right, do the math. There we go. And this one's in yellow and this one. They both say cosine 2 theta. Now I have 2 different formulas for the same thing. Why would I want to have 2 for 1? If I don't have cosine, then I could use this one. Of course, that means I have to have sine, right? Well, if we only have cosine, maybe we should do another substitution. So instead of substituting for cosine squared, let's substitute for sine squared. So solve this for sine squared and you would get, and then take that in, plug it in for that, for sine squared, right? Simplify. No.
-1.
Okay. So -1 and a, you said it. Okay, so how should we write that? The -1 first, the -1 second?
Second.
Okay, so the second one, right? So that kind of looks weird, right? So let's write it like what she was trying to say.
Yeah.
Right? Yeah, so now we have 3 for the same thing. Why do we need 3? It would certainly speed things up. Do we need 3? We don't, we could certainly be stuck with just the first one be done, but this seemed like like something we probably should do, and it resulted in something easier. Okay? So cosine, sine only gets 1 recipe, cosine gets 3 recipes, and the one that you choose is the one that you get. They have to give you sine or cosine, but maybe they only give you sine. Well, if they only give you sine, use the middle one. If they only give you cosine, use the bottom one. If they give you both, well, I guess you could choose any one of the 3. Okay, we'll see an example of that in a little bit. All right, so we did sine and cosine. We're got now tan. All right, so we know that this was the the sum formula for tan, right? So what was the drill that we did for the last 2 times? How do we get to the other formulas? What did we do? Replace everything with a theta, right? Theta plus theta is 2 theta. And then everywhere you see a theta, you're going to write, or everywhere you see an alpha and a beta, you're going to write theta. Okay, so what does the top turn into? What's the bottom turn into? The bottom does not turn into tan plus 1. It turns into Seth. You were so close. You said it right the first time, and then you changed your mind. The top turns into, there's 2 of them. 1, 2. Add them together, you get 2 of those. The bottom turns into, there you go, with a 1. Cool. Yes? All right, we better write all these down, right? How many did we get? We got 5 of these, right? We got 1 for sine, 1 for tan, and 3 for cosine. Which one of the cosines you use is dependent upon what they give you. If you forget all that, you can go with 3 of them, but you got to choose the cosine double theta is equal to the cosine squared theta minus sine squared theta. Having flipped the back of the book, does it give you all 3 or is it just give you that? Yeah, it gives you all 3.
Favorite math.
Geometry. I like proofs. I really like proofs. What are we doing today? This is the start of the slides. 2, double angle and half angle. So we'll do a couple examples of double angle. We'll move to half angle and we're done. I said of the 2, double angle is it's the straight, even though there's 3 for cosine, it's still pretty straightforward. It's the half angle that requires a little bit of thought for sine and cosine. But they're all just recipes that you follow. If I do sine, double angle, I need a sine and a cosine. If I do cosine, I need one or the other. If I do tangent, well, then I only need tangent. But if they don't give you tangent, then you need sine and cosine, because remember, tangent is sine over cosine. All right, good? You know the drill. We've done this plenty of times. Find exact values, establish identities. So here we go. What's the actual question to ask?
Exact value.
So I need to find the value of sine 2 theta. Okay? All right, what's the recipe? So what do I need in order to do this formula? I need sine theta and I need cosine. I need those 2 things that the blue arrows are pointing to. Which one do they give me? So I already got sine. I just need to find, how am I going to find cosine? Quiz. How are you going to find the other one? We draw a triangle. Okay, where does our triangle live? Where does theta live? Quadrant what?
One.
Quadrant what? Quadrant 2. This says theta is between 90 and 180. You see that? Theta is between pi over 2 and pi. That's quadrant 2. So we know that our angle, I just got to find cosine and I'm done. So I just need to find, well, cosine is an x value. I just need to find the x value and put it over r. Which angle does it give us? Or which ratio does it give us? What were we handed? Which one were we handed? Sine. Sine is defined as y over r. So therefore my y value is 3 and my r value is 5. I need my cosine, so I need the x value. What's the x value? What is the x value? Because that would be the cosine. I always start with the radius. Start with the radius. That's literally what r is.
So 5 squared.
And I don't even, I just go ahead and immediately square in my head minus the one you're given, and then take the square root.
16.
And then take the square root. But now look where we're at.
Negative.
So -4. So I know that sine theta is 3/5. It told me that. I just need to find cosine theta. I find cosine theta by looking at my triangle and doing x over r. And therefore x over r is -4/5. So I now have everything I need for my recipe. 2 is 2. Sine theta is, well, it gave it that to me. It was 3/5. And we just figured out that cosine theta was -4/5. I'm just following a recipe. 2 times 3 times -4 is all over you got a choice. What are we doing, Seth? Are we adding the fractions or multiplying the fractions? So therefore all over 25. Well, that would be true if we're adding. Does that make sense? Is there anything challenging there? No, because we've done 3 days of this, we know how to follow a formula, a recipe. We also know how to get the other thing. We draw triangles in the right quadrant. Okay. All right, let's do a cosine one. Okay, tell me which recipe we're going to use. Which recipe we're going to use? If you're on the ball, you're going to use the smart one, which is we're going to use the one that's signed. But let's say we weren't paying any attention. It's test day. We've forgotten all the stuff. You're going to say, well, the first one says this one, right? I'm not saying to use this one, but I'm saying if you forget and you're like, I guess I got to use this one. Well, then I got to use this one. This one requires you what? 2 things. I need cosine and sine. It gave me. So I just simply need to find cosine. I know once again I'm in quadrant 2 because it says you're between 90 and pi. Right? Everybody with me? Am I going too fast? Leaf, you with me? Okay. So I'm in quadrant 2. I draw my triangle. I got sine. Sine is y over r. So y is 3. R is 5. So x is -4. So for cosine would be once again -4/5. Okay. So it says take cosine, take the ratio and square it. So cosine is -4/5, square it. And it says minus the sine squared, so that would be 3/5 squared. Square 4/5 or -4/5 and you get? . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Put a minus sign and square 3/5. 6. 9 over. Seth. Thank you. 16 minus 9 is. 16 minus 9 is. Come on, you guys are making this painful.
Hold on, so 7?
Over.
7.
Okay, so that would be doing it the long way, but let's now do it the smart way. The smart way would have been using, and by the way, you all said the smart way from the start. 1 minus the what we're given sign. So let's use this. So, by the way, that's perfectly fine, right? Well, don't erase it. We got the right answer. But let's say this. Look, there's no triangle necessary because they gave me sine. Sine is 3/5. So what do I do with sine? Square it, then. That's not subtract. Square it, and then not 2.
1 minus.
No, that's not a 2. -2, and then add 1. Right? So that would be 3/5 squared times 2, technically times -2, right? And then add 1 to it. 3/5 squared is 9/25. 9/25 times -2 is -18/25. 25 minus 18 is 7 over 25. So I'm just going to point out, some people would argue that looks just as complicated as the first one. Well, what you're forgetting is that we had to make the triangle for the second one. The algebra, once you get to this step, is probably the same amount of algebra, right? Or simplifying, I should say. But the geometry wasn't there because we didn't have to draw a triangle. Choose wisely, but either one gets you to the right answer. Those two things are equivalent. 1 minus 18 over 25 is equal to 7 over 25. Does that make sense? Okay. All right. They're going to have one weird question tonight for homework. It's going to say, make a new formula. Like you come up with the formula. So it says, come up with a formula for not double theta, but for triple theta. And you're only allowed to have the words sine and cosine. Sounds complicated, but it ain't.
So do we just put a 3 instead of the 2?
Well, think about 3 theta. Is there a way to write 3 theta to be in a form that we know or understand? Well, how could you write 3 theta? Just ignore everything except for 3 theta. How could you write 3 theta? Mathematically.
Theta times 3.
Theta times 3, one way. That's another way of writing 3 theta. You're in kindergarten. How do you write 3?
That's fine. That's fine.
1 plus 1 plus 1. There's another way. Is there another way? 2 plus 1. Guess what of the 3 I'm going to choose?
2 plus 1.
Why 2 plus 1? No, because what did we literally do the last 2 slides? We did a double angle formula. So I can write 3 theta as 2 theta plus 1 theta because I have a formula for double theta. But wait a minute, take a step back. Squint your eyes so it looks a little blurry. What does this now say? Squint your eyes. What does this say? It says sine of something.
Alpha plus beta.
It's alpha plus beta. The only difference is alpha is 2 theta. We got a formula for this. We got a recipe for sine of alpha plus beta. There's the formula. Except alpha is 2 theta, and we got a formula for sine of 2 theta and for cosine of 2 theta. Right? There's your alpha, there's your beta. So if we write it like that, look, I got a sine 2 theta, and I got a cosine 2 theta, and I got a formula for those as well. Seth, what's the formula for sine 2 theta? So I'm going to take that first thing that says sine 2 theta and write what he just said. I'm going to take the cosine, but wait a minute, I got 3 possibilities. Okay, we have to write in terms of sine or cosine, so you have 3 possibilities. It doesn't matter which one you pick. I'm just going to pick the first one. So I'm going to rewrite sine 2 theta as 2 sine theta cosine theta. And I'm gonna write cosine 2 theta. I'm choosing, right? Any one of the three would work. I'm gonna choose the cosine squared theta, not because it's easier, and I just had to choose one. So I chose one. And then we just do the math behind it. We simplify. Hey, this first one, what do you notice? It says. So what could we do? I can't get rid of anything, but I can square it, right? Because there's two of them. So this would give me 2 sine theta. Yep. And on the second one, I distribute the sine to the inside and I get that. You notice anything over here? Look. Use your eyeballs. Look. There you go. I got 2 here. I got 1 there. That would give me 3. And there's your 1. Now, would it have done different if I picked another one? Slightly different, but I would have answered the question. So here's my formula. That's the formula for a triple angle, right? Did that make sense? Tonight for homework, they're going to give you something you can handle. Good? Oh, yeah. But I want you to remember in terms of, I don't know, brain power. Is this a high brain power requirement or medium brain power requirement? Oh, we're just following a recipe. It's just a medium one. Yeah, you got to do some algebra and some simplifying, but the reality is we're just following it. A little bit of geometry to draw the triangles, but in terms of challenging, this isn't the challenging part. Good now? Okay. All right, quick side note, sort of, kind of, right? I'm going to use this for the next thing we do. All right, these were my formulas for cosine, yeah? Each one was a formula. I'm going to take that one right there, and I'm going to solve for sine squared. It'll make sense in a few slides. I'm going to take this equation right here, I'm going to solve for sine squared. So I'm going to subtract 1 and divide everything by -2. If I do that, I get that. Right? I move the 1 to the other side, that would make it -1. Then when I divide by -2, it becomes positive, right? And the cosine becomes negative. Good? I'll do the same thing with this one. Solve for cosine squared. Add 1, divide by 2, we get that. Yeah? I'm just doing a little bit of algebra. So remember these two. You don't have to write them down, but just remember those two, right? And then I'll do the same thing with tangent, right? Tangent squared can be written as sine squared over cosine squared, right? Yes? But now look, right above it in yellow, it tells me what sine squared theta is. Sine squared theta is equal to that mess, and cosine squared theta is equal to this mess. So do a substitution for sine squared, cosine squared. See what I did? I made a big mess, right? Because this says cosine, and that says cosine. All I did was substitute for sine squared for this right here, which says 1 minus cosine 2 theta over 2. Guess what my next step? Copy dot flip. The 2's would cancel and you'd be left with that. Yeah?
Is this how?
No. This is how I'm going to prove the half one. So I get these 3 new identities that I'm going to use to get to my half angle one, right? So only reason I did this right here, granted they are new identities, one for sine squared, cosine squared, tangent squared, but I'm going to use them to get to my half angle formulas. Okay. All right, cool. These are not pretty or elegant. They are what they are. Okay. So half angle identity proofs. Here we go. I just said this previous slide. Yes, I just said this. All right. So now what I'm going to do is, well, instead of it being theta, what we're supposed to be doing half of an angle. So how do you make half of the angle? Don't overthink it. How do you make half of an angle? So everywhere I see a theta, I'm going to write divide by 2, right? So everywhere I see a theta, I wrote divide by 2. You see what I did? Hey, what happens over here with cosine? The 2's cancel, and I'm left with that, right? I want it to say sine theta divided by 2. It doesn't say sine theta divided by 2. How can we make it say sine theta divided by 2? Take the square root of both sides. But when you take the square root of a variable, you must, right? When you take the square root of a variable, if it says x squared equals 9 and I'm solving for x, if it says x squared equals 9 and I solve for x, what do you do to both sides?
Square root.
Take the square root, but what do I got to do to this side?
Closer.
I got to put a plus or minus, because there's two numbers that when you square it are 9, 3 and negative 3. So we just took the square root of a variable, theta. So what do we got to write? Plus or minus the square root. And there's our first one. I didn't say it was elegant or pretty. It also introduced the fact that we don't know whether the answer is positive or negative. Right? We've got a whole slide. We'll write it down here in a second. I'll do the same thing with cosine squared, except I won't run through it. Similar logic, we get to this one. Okay? Not pretty, right? All right, let's see where tangent comes from. Okay? So that was the one that we wrote before, right? So then clearly I need to divide by 2, because it's a half angle. So everywhere you see a theta, you divide by 2. What happens? It cancels, you're left with this, and we take the square root, we get this. Okay? So theoretically, that is the one for tangent. I say theoretically because it's not theoretically, it is true. It's just that there's an easier one than that one. But that's where it comes from. So it is interesting in the fact that that is true, but I'll show you an easier one. Okay. So here's the easier one. Yeah. There was your sine squared, right? We divided everything by 2. We got that. And we wound up with that. Yes? Okay. Now watch what happens. I'm going to stop right there. And instead of saying, hey, here's my theorem, instead of taking the square root, I'm going to multiply both sides by 2. See what I did? Okay. And then I'm going to simply do some magic. You ready for this magic? Ready for this? Here's the magic. Does sine theta equal sine theta? Yeah?
Yes,
Okay. Does this still say the same thing?
yes.
Yeah, because 2 times theta divided by 2 is still theta. But I did change something, right? So here's what I'm going to do. I'm going to take this right here. Left side equals the right side. So I'm taking that right there. Left side equals right side. Right? And I'm going to write the double angle formula for this. Right? Why is it double angle? Because it says 2 times theta over 2. Well, that's the double angle formula. What was the double angle formula for sine? 2 sine cosine of the angle. But this time the angle is theta divided by 2. So my left side still equals the right side. So this ugly mess in red right here on the left equals sine theta, yeah? Now this is magic because this part wasn't magic. The next part's magic. I'm going to go back over here in black on the right. I'm going to divide both sides by what's in red. I'm dividing by the same thing because it started off sine equals sine. Except the left side is ugly and the right side is still sine. So I'm going to divide my left side in black over here by the left side in red. And I'm going to divide the right side in black by the right side in red. You see what I did?
The bottom can, like the bottom sign cancels.
What cancels?
The bottom sign.
Yeah, one of them does. And then,
And then so you're left with sine squared theta.
yeah, but you said one sign cancels off the bottom. Well, if one cancels off the bottom, what's the other in this case? The top one. You didn't say that though.
Okay, but you know.
Well, I thought I knew what you meant, right? So what would you be left with?
Sine squared theta.
No, you said you canceled one off the top.
Yeah, but it's squared and the other one isn't, so you.
So you cancel one off the bottom, one off the top.
Still be left with one.
So it would be left with squared.
I don't remember saying sine, but, or squared.
You said so you left with a sine squared. By the way, it's being recorded. What happens to the 2's?
Cancel.
So you'd be left with a sine theta divided by 2 over, what's sine over cosine?
And
Yeah. You tell me, you want the one with the plus or minus square root, or you want this one? That one. So this is the one that they talk about in the book, they just don't show it in the back of the book. This is way easier to use. So we're gonna use that one rather than that one. You can use either one, but that one's easier. Okay, so let's write these all down. So I'm giving you the easy tan. Abby, flip the back of the book for half angle. Notice they give you the easy one as well too. Okay, so the book in the back does give you the easy one. So I said that the only thinking we got to do today is the half angle one for sine and cosine. Why did I saying that? Pointing to it. Because of the plus or minus. The hardest thing here is to figure out whether it's plus or minus. Yeah, but the restrictions, you got to do a little bit of extra thinking to figure out whether it's plus or minus. And I'll walk you through it. Everybody good? Okay, here we go. Hey, we did this before with subtraction, right? 15 degrees. 15 degrees can be written as, that's where we're going with this, but I'm saying 15 degrees could also be written as, yeah, but neither one of those are on the unit circle. 45 minus 30, right? So we could solve this one with the difference formula for cosine, but now we have a half angle formula, right? So remember, we could solve it this way, but we're going to solve it as 30 divided by 2, so we can use the half angle formula. Okay, so there's my recipe. Does this one involve a plus or a minus? Step number 1, figure out if it's plus or minus. So how do you figure out if it's plus or minus? Right, we're trying to find the cosine of theta divided by 2. So how big is theta in this particular case? If we're trying to find the cosine of 15, how big is theta? That's what we're trying to figure out, but we write it as a half angle, so how big is theta in our case? Is 30. So what quadrant is 30 in? Quadrant 1. Now we need to take half of that angle. Where do you live now? I still live in quadrant 1, right? What if it had been you're in quadrant 3? If you're in quadrant 3, if this is your theta, and we take half of it, where do you wind up? Let's figure this out. If you're in quadrant 3, right, it will tell you what quadrant you're in. If you're in quadrant 3, the biggest you can be is?
Quadrant 3.
The biggest you can be is, in quadrant 3 is? Where could you be if you're in quadrant 3?
270.
That's the biggest you could be. What's the least you could be? 180. So I don't care where you live in quadrant 3, you can be no smaller than 180 and no bigger than 270. Does that make sense? Now you take half of it. Take half of 180. Where do you live now?
90.
90, that's the smallest you can be. Take half of 270.
135.
That's the biggest you can be, so where do you live? I don't care where you started with in quadrant 3. If you take half of yourself, you live in quadrant 2. Okay? So that's the thing you got to think about for sine and cosine every single time. You start off with what's theta, not what's theta over 2, what's theta. In this case, theta is 30 degrees. And you take half of it and you figure out where you live. 30 was easy because we can take half of 30 and we know we're 15. We're still in quadrant 1. Okay? All right, cool. So we're in quadrant 1. And in quadrant 1, cosine is, well, we got to figure out what cosine is. It doesn't say cosine of theta divided by 2, it says cosine of theta. Well, what's theta?
30.
30 degrees. Do we know what cosine is at 30 degrees?
2 over 2. Or
That's 45.
1/2.
It's either 1/2 or it's
√3/2.
it's one of the two. Why is no one grabbing their unit
Well,
circle?
I know it's √3/2.
How do you know?
I know. No.
It is either 1/2 or √3/2. But check your unit circle. It's √3/2. Okay. So cosine of 30 is √3/2. So I write 3/2. The rest of the problem is just ugly algebra, ugly simplifying. Right? Okay. What do I do here? I gotta simplify that big ugly mess right there. Twos don't cancel. If I do a copy dot flip, what does this 2 turn into?
Multiply by 2 too.
You gotta flip it.
√6.
You always do this, Abby. You always do this. You yell out an answer, you don't answer the question, right? I ask you, what do you multiply by? And she's giving me an answer, right? For the rest of us, what are we multiplying by? I'm not mad at you. I'm just saying that you do that all the time. You are not multiplying by 2.
Why not?
Because it's, if you flip 2 over 1, you're multiplying by 1/2. If you're saying, but Mr. C, I meant you're multiplying the bottom by 2. I got you, right? But that's not what you said. You said multiply by 2. Okay, what's 1 times 1/2? What's √3/2 times 1/2? Multiply straight across.
√3/2.
√3/4. That's why she was saying 4, and I told her that. You're doing it again, Abby. Okay, now what?
Item
Okay, common denominator
4, so 2√3.
over. Okay,
Which will be
it's not yellow.
√3/2.
Think that through. Is there anything left that we can do? Is there anything left that we can do?
Oh, square root?
Can we take the square root of the top and get to an answer? You don't know what the square root of 2 is. You don't know what the square root of the square root of 3 is, right?
Oh, we can use our calculator.
Yeah, but it says exact. So can you take the square root of the top? Can you take the square root of the bottom? So the only thing you can do is
2 plus √3/√2.
you just need to add one thing to get to that right answer. What's on the top? No, you're leaving off one important thing. What are you leaving off? You said 2 plus √3, and I said no. What did you just leave off? The square root symbol. You never took the square root of the top, right? So it's the square root of 2 plus the square root of 3 all over 2. That was painful. Yes? Yay, trig. Did that make sense though? Okay.
Wait, I wasn't done.
I want to get 2 more done. I want to get 2 more done. Good? Okay. What's different with this one? Negative. So what's half of? I got to get to -15. So what's theta? -30, right? So if you take half of -30, what quadrant are you in? We're still in 4, right? So this one, that's all. If this had said tangent, we don't need to do that thing because there's no plus or minus for tangent. But for sine or cosine, we got to do that thinking. Half of -30 is -15. We're still in quadrant number 4. Okay. All right, cool. So formula for sine, half angle formula, is that. So what do I need? Not of theta over 2, but of theta, and theta in this case is -30. Woo, that was a lot to say. In quadrant 4, now here's, be careful, make sure you got this. I'm not worrying about cosine, I'm worrying about sine. So in quadrant 4 is sine positive or negative. In quadrant 4 is sine positive or negative. negative, right? So I know that the square root's gonna be negative, and I know that the theta is gonna be negative 30. Does that make sense? That's a lot of thinking. Remember I said this is the one you gotta think about. Well, cool, we just did this in the previous one. Hey, negative on the inside of cosine, guess what happens?
And it's even,
Even so it,
would be 30.
poof, goes away. Yay for us. And we just said the cosine of 30 was root 3 over 2. Now you just did this one the previous time, so what am I doing? Don't mess it up this time. So what am I doing? Yeah, but what am I doing? Multiplying the entire top by a half, copy dot flip, right? So I multiply the entire top by a half, that's going to give me. And then here. You gave me this part, but what about that? So that would give me distributive property with a half. You gave me the negative root 3 over 4. What's the 1 turn into? How many things on the inside? 2. So how many arrows do I need? 2. You gave me the first arrow. Give me the second arrow. Why are you thinking?
Negative 1/2.
It's not negative 1/2.
Yeah. I added positive. Okay. Yeah.
Positive 1/2.
1/2 subtract root 3 over 4.
Correct. Now what? No. Common denominator is 4. So what do we wind up with? No, you said common denominator is 4.
1 minus.
No, not 1.
2
2 minus root 3 over 4. Are we done? And by the way, it's negative square root of blah, blah, blah. Can we square root the top? And simplify. Can we square root the top and simplify? So it stays the square root of the top. That's simplified. What about the bottom? Turns into 2 and you're done. Is that the same answer as the previous one? Similar, the other one had a plus instead of a minus. Half angle formula. Yeah, it's weird answer, isn't it? Why do you expect trig to be easy?
Because it's a high school class and everything should be easy in high school.
Technically, this is a college level class. We're doing pre-calculus.
For this?
We are not, right? But next year you can. For calculus. All right. We'll do one. We got to do some thinking now. Previous ones were pretty straightforward. Okay. Hey, what recipe do I need? Half angle of sine. So step number 1 is figure out whether the answer is positive or negative. Okay. Notice the previous one, they told me the angle. They're not telling me the angle, but they are telling me where the angle lives. Where does the angle live? Where does the angle live? Count by pi's over 2.
420 divided by 2. That's wrong. What's the answer?
Count by pi's over 2. 1 pi over 2.
Pi.
So where does it live? 270. So it lives somewhere between 180 and 270. Is that where pi over 2 or is that where, I'm sorry, is that where theta over 2 or is that where theta lives? Look at what it says. That's where theta lives, but we need theta over 2. So if you start off in quadrant 3 and you take half, where did we say you wind up? If you memorize that, you're okay. Could we memorize them for all 4? We could. If you start off in quadrant 1 and you take half, guess where you wind up? 1, right? If you start off in quadrant 2 and you take half. Well, here would be my limits. The largest number.
180 to 90.
So if you take half of 180, you wind up with.
90.
So that means you also wind up in quadrant 1. If you start in quadrant 3, you take half. Half of 180 is Half of 180 is?
Half of 180 is 90.
So that's the smallest you can be. Half of 270 is. So if you start off in quadrant 3, you wind up in quadrant 2. The last one is quadrant 4. The smallest you can be is this. Take half of that and you wind up in, well, that's 135, right? The biggest you can be is 360. Half of 360 is?
180.
So where do you wind up?
Quadrant two.
Quadrant 2. So when you do this half angle, you only ever have two options. You either wind up in quadrant 1 or quadrant 2. That's it. There's only options. If you start off in 3 or 4, you wind up in 2. If you start off in 1 and 2, you wind up in quadrant 1. And the only reason we need that is because if we're doing sine or cosine to figure out whether the square root is positive or negative. So we just determined that we started off in quadrant 3, we wind up in quadrant 2. We start off in quadrant 3, we wind up for the half angle in quadrant 2. So for sine in quadrant 2, are you positive or negative? You are positive because it's the y value and the y value is positive. Right? Yay us. Okay. All right. Hey, it already tells me what cosine is. Look, it told me what cosine was. No math involved. It says cosine is -3/5. I don't have to look at a unit circle because it told me what it was. The only thing left to do is this algebra. Just simplifying. Multiply by 1/2 and you get
1/2 plus 6/10.
so close. 1/2 plus,
3/10.
okay.
So
Now add those two together. You get 8/10. Why did I do it differently than you? Because I simplified the numerator before I distributed the 2. Okay. The reason why we had to be multiplied top and bottom by half the previous one because we had a variable. We don't have a variable now. Okay. 5/5 plus 3 is 8/5. Yes? See where I'm getting the 8/5 from? Do a copy dot flip and you get? Evelyn, because I chose to, the way you did it is fine. We'll do it Evelyn's way. She said do the square root of parentheses 1 plus 3/5 times 1/2. Yeah? So that would give us the square root of 1/2 plus 3/10. Common denominator is 10, so multiply top and bottom by
5.
5 plus 3 is.
Oh.
What I chose to do is I chose to do 1 plus 3/5. That would be 5/5 plus 3/5, which is 8/5. I do a copy dot flip, and I get now I'm where Evelyn was 8/10. Can't take the square root of 10, so you got to multiply.
What if I do it?
You're going to get 8/10.
Yeah, but I just got 8/10.
We got the same answer, Evelyn. We got the square root of 8/10. We got the same answer. Okay. Can't take the square root of 10, so we got to multiply top and bottom by. Oh, you want to change this to 4/5 first? Okay, I didn't do it that way, but we'll do it that way. So you get the square root of 4/5. Now what? Can you have the square root of 5 on the bottom? Square root of 4 is 2, and the square root of 5. Can you have the square root of 5 on the bottom? So what do? So final answer, 2√5/5. All right, I chose to do that. All right. I still got 2√5/5. You got lots of choices in life, you know. Cool?
Mm-hmm.
All right, we finished on time.
How much minutes do you?
30 seconds. I had another one, but we're out of time. Did we ever do any tangent ones? Tangents are the easy ones. There's no thinking involved because there's no plus or minus. There's no worrying about where you're at. All right, that'll end it for today.
Maybe I might as well